Draft science video. Yeah, I don't have anything specific. I'm just going to make this video because I've wanted to make it, and I just, so I'm doing it for my own sake, I guess. And, you know, the audience in these videos is pretty low anyway, so maybe just get my own thinking going. And, but it's on this gravity acceleration thing, and the mechanisms that are creating it, and, yeah, conceptually understanding what's happening with matter and how this gravity phenomenon is generated through the condensation of light. Yeah. And condensation would mean, okay, by my standards, my definition, I think this word, you know, the spin is going to be important. I think spin is an interesting concept. So what I'm basically arguing is that light is trapped. So if this was a photon, and it would be trapped, like in an electron, so there's a whole trapping mechanism, so let's say they're swirling around each other, like I've said before, the double helix idea of a string of photons weaving around each other would alter their speed. So their speed from point to point would change depending on how fast they were rotating in that helix. And over here, you can sort of get the idea that their ability to traverse time is changed based on how much, you know, there's all this extra movement that can be in their getting from one place to another, which would mean they would slow down. So if you had an electron that was made something like that, and then you had that trapped on some sort of axle, and so it spins around that center point, you know, you have the formation of the structure of an atom, the traditional notion of an atom, let's say, and that the consequence of that, when matter is in that configuration, it becomes what we call matter. And we now say it's got some of this G stuff. Okay, G has now been created. You know, it has this gravity thing happens, and when you have this mass thing, so this creates mass, and it creates gravity. You know, when you do this trapping thing. And when you combine a whole bunch of those, you end up with a lot of gravity, and then all of a sudden you have bodies outside of that gravity that are now going to be pulled. And so now we could just say this was a planet. Well, I might as well just draw another picture. And so my argument is that something out here that's being pulled by gravity into this this mass, right? This big mass now. Yeah, big mass. You know, there's this idea that it's flowing. There's something carrying it in. You know, there's a stream that's pushing it in. You know, a field or something like that. It's just on the stream and it goes with the flow kind of idea. And I'm arguing that no, the movement, any movement something has through space. So if I have an object and it's moving through space as something with mass, a matter, the problem is that its internal dynamics is still made out of light. So what I'm arguing is that any mass has a light potential, you could argue, in a direction. Like every bit of the photons are all moving, and they're moving at the speed of light. So they're all trapped, moving at the speed of light, but they're doing it in these configurations. They're in arrangements inside of the thing. But the idea I'm arguing is that, you know, obviously depending on how they're rotating, there's you can't multiply, you can't add to their speed. So they're already moving the speed of light. So if you push something in a direction, what you're basically doing is saying, okay, if there's a rotation of the rotation of a photon is in the same direction that you're pushing it, there would be a necessity that this photon move faster than the speed of light, and it can't do that. So the compensation has to be that there now has to be extra movement, you know, in some compensating direction. because you're not going to be able to take those extra squares, those extra bits of space. The photons will not be able to do that. So in essence, they're going to have to be pushed backwards. The atom itself, the electron, whatever the photon is part of, will not be moving forward. It will not comply with the request to go forward. And so what's going to have to happen is it's going to take extra steps to compensate in the opposite direction. And so it's going to change its configuration is the real point. And so what I'm arguing is that when something's moving through space, it's not moving through what creates momentum, we'll call it the big mo, is that the matter itself has been rearranged. So now the net potential of the photons, that is, more photons are moving in that direction than are moving in that direction. And so that's why the matter ends up maintaining its movement, is because the atoms themselves are so arranged as the net pressure of their photons is in a direction. So this is why matter can't be accelerated without it degrading eventually. As you go really fast, the matter itself just breaks down, because now the photons have to, more and more of them have to be moving in one direction, the direction of the movement. So the faster you move something, the more the photons all have to be arranged in that direction. They have to be going in that direction. And the ones going in the opposite directions there's less and less. And so obviously you can't maintain any kind of round structure or balanced structure in a circumstance where you're forcing a huge percentage of them to all be arranged in the same direction. So once you have established this movement in a direction, you start degrading the balance of the matter, the vibration of the matter, however you want to think about the matter. The matter is going to start to degrade as it's moved. There's going to be the bonds, the things holding it together are going to start breaking down. These strings that are tying, say, if you were to think of this as an axle with a string forcing the electron in a circular movement, it's going to start breaking down if this is one direction is the only direction all the photons have to be going in, to be able to have a movement in a direction. Obviously there can't be any balance anymore. There can't be a positive stroke this way and a negative stroke that way that's balanced if you're moving in a direction. They've obviously got to be arranged in some sort of imbalanced way to create that momentum or that movement. And so when something's moving, it's because their arrangement is that there's a net pressure on the photons in a direction. So there's the photons, as the atoms are arranged, will oblige. There's more movement of photons in one direction than the other direction. And I would argue that could be accomplished by just understanding electrons as being in when they're in an orbit, as being in an orbit that slightly doesn't meet, so it has a hook to it. And so as it spins, it's always going to eat space in one direction, in one place. It's going to eat space in a direction. It's going to be constantly obliged to tend to move in a direction, because it's going to be eating space in this little bit of a direction. So you can kind of think of this as if this was moving in a spiral. It's quite easy to understand how that would slowly just screw itself through space, and it would be moving in a direction. So even though it's a kind of a stable condition, in that it could do this forever, spinning, it's going to spin in that direction. And that's sort of what happens when something's moving, is most of the atoms are now arranged in such a way as the opening, the excess, the biting off part is in the direction of the movement. So now all the orbits are tending to be forced into an arrangement where they're eating space in the direction that the thing is moving. And that would account for the movement, obviously. And like I said, there's a point when you start going fast enough where this bite isn't big enough, where you can't, I would imagine you can stretch the bite, and so you know, the bite might start off being this way in stable perfection, and you can start making them less and less stable by having a bigger and bigger bite taken with the orbits. But there's probably a limit to that, where eventually you're going to break the electron's connection to the atom, and eventually the bite will be so wide that the electron will essentially be released in a direction, and will no longer be connected to that in that orbit. You might get caught up in a new orbit, but I'm just saying you'll start breaking the chemical atomic bonds holding the electrons to the atoms with enough speed. Yeah. So this all comes down to this acceleration. So when gravity is happening, what I guess I'm arguing is that there's something changing the matter itself. So the matter inside the object that's getting pulled by the gravity is being changed by this force of gravity. We'll call this the force. And that's somehow provoking this net change in the orbits of these electrons, that they're now going to bite off bigger pieces in the direction of the gravitational object. And so what would these forces be is the question. What is this configuration of energy, this configuration of changing force, changing mechanism? And so what I'm thinking on that now is that, well, we have this electromagnetic scale, you know, and we got light here somewhere in the middle. Let's say this is visible light, and you know, you got the gamma rays and stuff over in this extreme end, and you got radio over here. And these are all photons moving at the speed of light. And you can sort of understand the upper limit's going to be decided by the Planck constant. You know, the minimum distance, the minimum wavelength is going to be defined by the Planck constant, in the sense that you're not going to be able to go smaller than the Planck constant that sort of establishes the speed of light. But the lower limit is where there's like this opening, like, well, why couldn't these wavelengths get to be 10 miles? I mean, you have lots of ways of describing, you know, radio signals. They start talking about 10 meter and 20 meter, and you know, these very long wavelengths of radio waves. And I don't have a hard understanding of exactly how a photon gets to be that long, whether photons are a string of quanta, you know, and it's how many quanta are in a string that determines the, you know, what it is that we're talking about when we're talking about a wave. Because a radio wave really is just a bunch of particles. It's just that it's not directed, right? I mean, so a radio wave just radiates in all directions, you know, from a source. It's not focused energy at all. It's not a laser beam of directed photons. It's, you know, dispersed like a light bulb produces light. It's dispersed in a shell of, and it's a very regular, because it's a very slow vibration, a very slow release point. You know, it's going like this, you know, very slow by comparison to, you know, light that's very quickly, you know, the very high frequency of incidence of creation. The photons are being released very quickly, where in radio waves the string or the photon is being released slowly. And the length of it could be the way it's released off, say, an antenna. You know, the photon might release as a, you know, it peels off of the antenna, and that's why the antennas have to be a certain length to produce certain kinds of radio waves. It's because the photon is essentially peeling off of the wire or the antenna instrument. But that's a whole nother. That's not the technical issue. The point of me bringing that up, radio waves, is that maybe it is gravity. The fields created by gravity are essentially very low frequency photons, that are affecting the matter, that's creating the change in its arrangement that creates the acceleration towards the center. So that this is a physical dynamic, not a force dynamic. That there's an actual configuration of photons here in the environment, and these photons are interacting with the matter, creating a vibration in the matter. Vibration. Yeah, we need a good vibration signal, but that doesn't look like something else. But I mean, it's matter is always vibrating, and this gravity is a vibration of a, like I said, we could make it a mile. We can make the frequency almost anything, the wavelength, and so at these very low frequencies, the vibration may have a significant impact on arrangement of the matter, and cause, like I said, but these are real interactions taking place in the matter with photons. So the photons are carrying a vibration with them based on their configuration, and that vibration is being transmitted into the atomic structure, just like it is with all interactions with photons interacting with matter. I mean, photons come into matter and they change the arrangement of these orbits. They interact with the electrons, create a blue photon will come in and a red photon will be released, and the orbit changes. Its eccentricity is changed. That might be something to do with this whole orbital change thing, of the fact that the orbits do, how much overlap is in an electron in its orbit is what is traditionally called the energy level of the electron. And so the low energy electron would be the one that's got a very tight gap, and the high energy would be one with a very high gap. And these two electrons would react very differently when encountering a photon. A photon might tighten this electron, where a photon might loosen this electron. I mean, widen the gaps. It would change the gapping on these electrons. So obviously we can say that photons would have that ability in matter, and clearly these high frequency photons would have the capacity to change this gapping, and that these photons have to be radiated to be able to create this effect. So I guess I'm arguing that matter, when energy, when mass is created, when you create an atom, and you create this orbit, that you are likely also creating the release of some form of weak energy in the form of radio wave photons. And we might see that in the decay of very heavy elements. They have a decay rate, and that decay rate might have something to do with this fact that all atoms are decaying. They're just decaying very, very slowly from our perception. It's hard to put an atom in an isolated environment where it has no influences, no external influences. So I mean, how much radiation is created by how much radiation is going in? It might be an interesting question. Yeah, I don't think I'll go there though. I'm just thinking that it could be some sort of thermodynamic issue where gravity is dependent on how hot the environment is that the gravitational body is, like how hot the universal environment is. So how much bombardment by photons is happening would change the gravitational impact. but I don't know what experiments could be done to verify or validate or non-validate that, just because it's too big an experiment to have to do. Gravity gets very hard to test in the noisy environment of small Earth. So doing gravity experiments with small objects is really hard to do, just because there is so much noise in the environment, and it's so difficult to insulate against all that noise. But anyway, it's really probably not terribly important. I guess the important thing to understand is that the atom is to the apple, okay, with the apple is to the Earth. So there's a lot of atoms inside of gravitational bodies. So you can just imagine how little gravity an apple has, and yet it has as many atoms in it as a Earth has apples in it. So that's recognizing just how small an impact each atom is having on the end product of gravity is kind of a significant thing to recognize. So let's say there is this little bit of leakage of energy, gravitational energy, out of every atom. That little tiny bit added up in zillions and zillions and zillions and zillions and zillions of atoms, it becomes a net force eventually. It's a substantial force just because of the collection of it. So the tiny force is all condensed in one object, and now the significance of that radiation is feelable by an object outside, because now the force it's all consolidated. It sort of makes sense. And then it gets down to the center of gravity thing, because that's another point here, is that it always turns into a center of gravity. Just like these moving objects, you can spin them, on their center of gravity, and it would make no difference to anything that's happening. So that as they're spinning, they're still being pulled exactly the same. So somehow the arrangement does have a center to it. So as the atoms are being rearranged, as these bigger gaps happen, they're still happening in a coherent manner to the atomic structure. So, that creates this idea of a center of gravity, that everything still has to be tied to all the other pieces. There still has to be kind of a rubber band effect that keeps things tied together. So the idea that there's a coherency to a center, so it just has more to do with how, when you're connecting all these little these rings of elements, that ultimately there's no way to separate them from the fact that they are contained, that they don't escape the container. So the forces holding them together are such, the bonds are strong enough that you're not going to release the atoms themselves. And as long as they're in such a container, there'll always be a rebound or a bounce to their center. Because whatever force is tying the chemistry together, the atoms together, is strong enough to oblige a kind of rebound, a kind of, you can't go here, you're going to be forced back here. So that'll automatically create a center. Is just the idea of having it in a container would create the same effect, where it could only, if it tried to go this way, it's going to bounce back this way, and that will automatically eventually create a probabilistic density in the center. Let's see, how's a good way to explain that? But you can see that obviously, though, as things do accelerate faster and faster, they are degraded. This structure starts degrading with friction or some other mechanisms, and you'll start losing atoms, and the thing will melt. It'll get hot, and lots of things can happen that'll degrade the matter further and further, and degrade this cohesion between the atoms. The forces, the strings tying atoms together, will start to break, and you know, the continuity will start to break down. Yeah, well, this is enough of a messy drawing to satisfy me for now. But yeah, understanding gravity not as a invisible force, but as, you know, actual an actual mechanism of photons that are impacting atoms in the matter and changing its configuration, so there is a net photonic pressure, we'll call it, a net photonic pressure in the direction of the center of the gravity. And I think that does explain movement. It explains why things keep moving. Once they're moving, it's because they have an arrangement, and you have to rearrange them to stop the atoms from moving. But the thing itself moves. When you push something in space, you just give it acceleration, you're basically changing the configuration of the matter, changing the configuration of the atoms, and they won't be rechanged until some force acts on them to rechange them. So if you move them into such a way where they're all doing this biting, they're biting space in this direction, you have to change them so they'll bite space in some other direction. That you have to move them physically in their orientation. Something has to change that orientation. It doesn't spontaneously change. So that's why it'll just perpetually keep moving, is because until something tells this thing it has to go in a different direction, it's going to keep biting space in that direction. Yeah. Something like that. So it gets a little complicated because the thing that's creating some of the balance here is the vibration of the matter itself. The fact that the internal dynamics are just as frictionless. So any vibration inside of matter will go forever, because there's no friction inside, you know, on this atomic level. So if this releases a photon, and that photon goes into this atom, and then this atom releases and it goes into this atom, that photon will just be released and captured indefinitely, because there's no friction preventing that constant interaction. And it's that dynamic that likely holds, that's probably the force that's actually holding atoms together, is the sharing of these exchanges of photons and the reorientation of these bites into each other, and that there's a net balance to that. Let me see. You know, there's no. I'm trying to think of some way to say it, where it's like something in water, a pattern. And if you vibrate it a little bit, the pattern remains. If you vibrate it too much, the pattern falls apart. But it's like a bunch of tiles floating on water, and you can have movement in them, but only a certain amount of movement. And if you create too much movement and the waves start peaking, then all of a sudden the pattern, they'll start breaking. And so I guess it's some kind of mechanism like that that maintains the structure. The internal frequencies aren't aggressive enough to break down this dynamic once it's established. So once there's an established directional potential of photons in a direction, the internal vibration moves it but doesn't break it until something extra comes in and changes the balance. Like some other gravitational photons, some other, it's probably a gravitational wave. Yeah, some gravitational wave passes through the matter and reconstructs, is aggressive enough to disrupt the pattern. Yeah, that might be the way to say it. So anyway, yeah, I mean, this is getting somewhere. I just have to, you know, but what I like about this this way of thinking of it, is that all of this can be created out of a thing. You can just have a piece of thing called quanta. Okay, quanta. And this would just be quanta in mechanical relationships. So there wouldn't be any of this this force idea. Everything would be made out of these little bricks, and they were just little bricks in different arrangements. With little bricks moving the speed of light in a direction, and that's what the whole universe is made out of. So whether it's photons or quanta, that's going to be the tricky question. Whether photons are actually made out of quanta. Is something I haven't resolved yet. It seems to me that it would make sense that you would be able to create the different kinds of photons on this electromagnetic spectrum that you can't see anymore right here, that the way you would create these different photons, gamma rays, visible light, radio waves, would be to have more or less of these quanta, or have the quanta separated by more distance, or some other physical mechanism that would create what we have as the different representations of a photon that seem to have different qualities. I mean, the irony is that the thing I'd have to explain is the high energy level, okay, of a very small photon, wavelength size wise, and the relatively lower energy of the much more massive photon. But like I said, so for that sake, in that argument, you almost have to say that the photons are stretched rather than made of multiple quanta. Because if they're made of multiple quanta, then you'd say that the radio wave should have more energy than the gamma ray or cosmic ray. And it doesn't appear so. But what energy it has really has to do with what happens to atoms when it impacts atoms. So it might not be a function of its energy, it just happens to be a key that opens the door easier. That it releases energy from atoms easier. It doesn't bring more energy into the system, it just releases more energy from a system that already exists. Yeah. So I have to think some more on that one. Anyway, just wanted to get this in there so gets me thinking about it. And I need to do more. I need to spend a little more time on this. I'd like to spend more time on it. That's what I probably should say. So anyway, classic Emendem drawing, I'd say. Yeah, pretty classic. Anyway, till next time.